Good day, everyone. This is Mama Doko, and this is the continuation with our topic percentage, ratio, and proportions. So, our topic for today is ratio and proportion. Our lesson objectives are define ratio and explain how it is used in the business, define proportion and discuss how it is used in business, differentiate the direct proportion, inverse or indirect proportion, and partitive proportion, and apply them on business. If we are going to define what is a ratio is a relation between two numbers of the same kind. It is a comparisons of two numbers or measurements, or it can be a comparison of two values, like how much of one thing there is compared to another. Like example, I have here one blue square, and then also I have other two white squares. So we can see here, so one blue square and two white squares. So these two different colors of squares are compared to one another. So how can we express ratios? So ratios can be shown in different ways. We can use column. Okay, so this is how column look like. Two dots to separate the values. Okay, so I'm going to use our example. So we have one blue square is two white squares, or we can use the word two. Okay, so one is two, or we can write it like a fraction. Okay, so 1 over 2. So we can see that the two values are separated by a fraction bar or a Venn column. Okay, so ratios are generally used in cases of partnership, sharing of profits and losses. Like for example, there are two persons and they have an agreement that they are going to share their profits and losses in the business, so they can apply ratios. There are two ways of finding ratios. So one way is part to part, and the other way is part to whole. Okay, so when we speak of part to part, it means comparing one part to the other part. Like I have an example here. If there are 40 men and 60 women, find the ratio of men to women and the ratio of women to men. Okay, so the problem is asking for the ratio of men to women. To find the ratio, so we simply perform division by dividing the 40 men by 60 women. As I discussed earlier, that we can express the ratio as a fraction. Okay, so then reduce to lowest terms. So we can cancel the zeros. Okay, and then so we need to reduce it to lowest terms by finding the factor that is common between 4 and 6. Okay, so 4 we can divide by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. Okay, so our ratio is 2/3, or we have 2 men is to 3 women. Okay, so that is the ratio of men to women. And then finding the ratio of women to men. Okay, so we follow the same method by division. So we have 60 women by 40 men. Then we cancel the zeros. Then look for a factor or a term that can divide these two numbers. Okay, so 6 divided by 2 is 3, and then 4 divided by 2 is 2. Okay, so our ratio is, we have 3 women is to 2 men. Okay, so that is a ratio of part to part. Another way of finding ratios is to find the relations between part to whole. Like I have an example here. If we have a total of 100 shirts of 30 small-sized, 50 medium-sized, and 20 large-sized shirts, so find the ratios of small, medium, and large shirts. Okay, so we need to determine the ratios between the 3 sizes of shirts. Okay, so the problem shows that there are a total of 100 shirts. Okay, so there are a total of 100 shirts. And it means that out of 100 shirts, there are 30 small-sized shirts. Okay, so this one, small. And then also the same quantity of shirts, total quantity of shirts, 100, there are 50 medium-sized shirts. And then out of the same quantity of shirts, there are 20 large size of shirts. Okay, so what do we have now? Here are fractions: 30 over 100, 50 over 100, 20 over 100. Okay, so the numerator, the 30 represents the part, and then the 100 represents the whole. Okay, so our ratio will be 30 is to 50 is to 20. Okay, so if we are going to add all the numerators, okay, so it will be equals to 100. So it means that for 100 shirts, there are 30 small, there are 50 medium size, and 20 large size shirts. Okay, then we need also to simplify our ratios. Okay, so only cancel the zeros. Okay, so we have 3 is to 5 is to 2. Okay, then if we cancel also the sum, Okay, so it means that for every 10 pieces of shirts, there are 3 small size, 5 medium size, and 2 large size. So our ratio is 3:5:2. We have here a problem for ratio. A chocolate cake requires an average of 1 hour of baking time, while cupcake requires only 20 minutes of baking time. What is the ratio of baking time for chocolate cake to that for the cupcake? Express your answer in simplest form. Okay, so the problem is asking for the ratio for the average baking time of chocolate cake and for the cupcake. Okay, so for the chocolate cake, okay, so the average is 1 hour to bake. And then for the cupcake, okay, the average time is 20 minutes. Okay, so we can observe that for our time, the units of measurement is different. Okay, so we have an hour and we have minutes. Okay, so as I discussed a while ago, ratio is the relation between two numbers of the same measurement or the same kind. Okay, so this one is not the same, hour and minutes. So what are we going to do? We need to convert the 1 hour into minutes. Okay, so how to convert? Okay, so we know that there are 60 minutes in 1 hour. Okay, so we perform the conversion. Okay, so in 1 hour, okay, there are 60 minutes. Okay, so cross out, so we have 60 minutes. Okay, so it means the average time for baking chocolate cake is 60 minutes. Okay, so what is the ratio? Okay, so now we have 60 minutes for the baking time for chocolate cake to 20 minutes the baking time for cupcake. Okay, then we can reduce it to lowest terms. Okay, so 60 divided by 20 is 3. Then 20 divided by 20 is 1. So our ratio is 3:1. And always remember that a ratio has no unit because we are comparing the same measurement.